We have 10 digits, starting at 0, 0 through 9. So when we're counting, we go like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's pretend that we had prefaced all these with zeros just to indicate that there was another column available to us. We have a ones column and we have a tens column. Now since we only have 10 digits, since 9 is the highest digit we can have in this counting system in base 10, we have maxed out the capacity there. So if we want to add 1 to 9, what happens? That one zeroes out and we carry 1 over to the next column. And then if we're cruising along, we continue to count and we get to 19. Again, we have maxed out what that column can hold. So when we want to add 1 more to it, what do? We zero it out, we go back to the minimum, and we add 1 to the next column. And so on. So if you were sitting there, you know, at 0, 99, and you wanted to increase this one, well, what does that one turn into? 0. And then we carry a 1, we add 1 to the next column. Well, that one's also maxed out. So we set that one to the minimum, and we add 1 to the next column. That's how you count in decimal. We already know that. So if you have the number 329, what this really means is 3 times 100 plus 2 times 10 plus 9 times 1. Because this is the hundreds column, this is the tens column, and this is the ones column. Or you could say that this is 10 to the power of 2, this is 10 to the power of 1, and this is 10 to the power of 0. But now we're going to count in binary. Let's give ourselves a little bit more room. Okay, we add 1 to it, 0 becomes 1. But binary only has 2 different kinds of digits. What happens now? We want to add 1 more to it, but we've already exceeded the maximum capacity of this counting system. So the 1 becomes a 0, and we carry 1 over to the next column. We add 1 again. Now we want to add 1 to this column. This is kind of like when we hit 99 in the other one. That one's maxed out, so it becomes a 0. We carry the 1 over and we add it to that one. Well, that one's maxed out too, so that one becomes a 0, and then we get 100. Well, 100 in binary. And so if we were assigning decimal equivalents, that would be a 0, that would be a 1, that would be a 2, that would be a 3, and that would be a 4. That tells you a lot about the values. 1, this column is the ones column. This column would be the twos column. And then this column would be the fours column. And if we carried it out to 1 digit further, what's the next column going to be? Pretty easy pattern to pick up. 1, 2, 4, 8, because it's actually doubling each time. Yep. So if we wanted to come up with a groovier way of saying this, we could say that we had 2 to the power of 3 in this column. Then we had 2 to the power of 2 in this column, the next one. We had 2 to the power of 1 in the next column. And we had 2 to the power of 0 in the last column, because anything to the power of 0 is 1. So let's just pick a random number. 1, 0, 1, 1. That is the same thing as saying 1 times 2 to the power of 3 plus 0 times 2 to the power of 2, 2 times 2, plus 1 times 2 to the power of 1, plus 1 times 2 to the power of 0. Which, if we wanted to simplify, what's 1 times 2 to the power of 3? Well, that's 1 times 8. Let's just skip that one entirely because that one's 0. Plus 1 times, what's 2 to the power of 1? That's 2. It's that column. And then lastly, plus 1 times 1. So this number here, 1011, is equal to 8. It doesn't have any 4's in it, but it does have a 2, and it does have a 1. So 8 plus 2 is 10 plus 1. That's equal to 11. What about 1100? What would that one equal? If we were going to do it long form, let's skip doing it long form. What's this column? That's 8. So it's got an 8. Does it have any 4's? Yeah, so it's got 1 times 8 plus 1 times 4. Does it have any 2's? Plus 0 times 2 plus 0 times 1. So what is that equal to? Yeah, it's an 8 plus a 4. So it adds up to a 12. So go to your Dropbox. I don't know why I put it down at the very bottom. Let me push it up to the top. Alright, if you refresh it, you'll see in class assignment 2. It actually should be called 1. I'll change the name of it to in class 1. But anyways, it's that one that says binary and hex. Go ahead and open that Word document. And we'll start filling it out. Dropbox, refresh the Dropbox. Here's the attachment. It says notes on the 29th. It's really the 30th, but that's okay, isn't it? Let's open it up. And here we go. So 1011, we did that one. Or we did something very similar to it. That's 1 times 8 plus 1 times 2 plus 1 times 1 is equal to 11. Now how about this one? 0110. Let's skip the zeros. What's the first one we see in this one? Yeah, so that's 1 times 4 plus 1 times 2 is equal to 6. Go ahead and fill in those other 3 slots. And you may get annoyed by typing that 1 times each time, but in other counting systems you can have more than 1, you know, in each column. What if it was 5, 3, B something, you know? Okay, 1 times 4. So the highest value that can be stored in 4 bits is 15. The lowest value is 0. So there's 16 different numbers, 16 different combinations out of 4 bits. And that turns out to be a pretty easy. 4 bits equals 16 values, which we'll say are 0 to 15. 16 is 2 to the power of 4. If you have 2 bits, that's 2 to the power of 2. So how many different combinations do you have there? You just have 4 possible values. So the highest value in 2 bits is a 3. And that makes sense because if you have 1, 1, what does that equal to? That's equal to a 1 plus a 2. That's a 3. What about 4 bits? That's an 8 plus a 4 plus a 2 plus a 1. If you have 8 bits, that's even more than that. 2 to the power of 8 is 256. This should be 2 to the power of. So 2 to the power of 8 is 256 different values. So you can count from 0 up to 255. So with 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. Not only do you have a 1's place, a 2's place, a 4's, and a 16th, but you have a 32, a 64, a 128. I think I've added too many ones here. Let's count that again. 1, 2, 4, 8, 16, 32, 64, and 128. So if you had to, and I won't ask you to do a number this large, you know, if you had to figure out what that was, that would be a 2, but there's no 4s, plus an 8, there's no 16s, plus a 32, there's no 64, no 64s, plus a 128. So the fact that 8-bit values, the maximum value you can store in 8 bits is 255, sometimes that would cause bugs in old video games. And the most famous of which is Pac-Man Screen 256. You could play 255 levels of Pac-Man, but then when you got to 256, it would roll over and try to draw level 0, and it didn't know how to draw level 0, so it was completely garbage, and you couldn't finish the game. So, you know, that was the end. You could not play more than 255 levels of Pac-Man. You couldn't finish the game. And there were other video games that had the same problem. That's overflow. You have filled up all of the bits that your counting system can contain, all the places, and then you want to add one more to it. Well, they all turn 0 again. So you've lost some data. That's called a overflow or data overrun. Java uses 32-bit value integers. 32-bit integers. And so that's 2 to the power of 32 different possibilities. And honestly, I don't remember what 2 to the 32 is. Pretty large number. Now, however, it also keeps track of negative numbers. And the way it does that is the first bit determines whether the number is treated as positive or negative. So I'm going to go back to an 8 bits. 8's easier to remember. If I have 8 different places, and the first bit is being used as a sign bit, if the sign bit is 0, that's a positive number. And so a 0 followed by 7 ones is equal to 127. However, if you flip that, this is not exactly accurate because it uses something called 2's complement, but this is close. That would be minus 127, or minus 128. Let's say that it's 128. I hope that's correct, because this would be 255 different values, plus one more for 0. So you have a range of negative 128 going all the way up to positive 127, and if you include 0 in that range, that's 256 total values. So when I did 2 to the power of 32 in Google, and I got that it was equal to that, well, really, the highest number it could contain would be half that positive and then half that negative. I just kind of want to introduce you to the idea that the more bits you have, the higher the values it can contain. There's also another form of integer called a long. It's 64-bit. It can hold a much larger number still. 2 to the power of 64. Okay, let's go back here. The next thing in our worksheet is counting in hexadecimal. Hexadecimal, the idea behind hexadecimal is, let's say we had a series of numbers, 0111. I'm going to break them up into clusters of 4. If there's 8 bits in a byte, there's 4 bits in half a byte. This will make kind of sense. Okay, let's figure out what these are. Well, firstly, let's just make a little chart. I don't want to have to think this hard. What's next? I'm counting. What's the next after that? 0011. I want to add one more to it. 0011. Right. And then what's after that? Yep. Everybody in agreement? Okay. All right. And so that's a 0, and we're not going to take the time to add up the powers of 2. We're just going to take it on faith that we can count like this. Now let's come over here and do 1 0 0 0. That's an 8. That would be a 9. 10. 11. 12. 13. 14, and 15, for a total of 16 different possible values. So that's an 8, 9, 10, whoopsie, 11, 12, 13, 14, 15. So we want to turn this into a series of something that's easier to read, like on a screen. We don't want a screen, a whole big screen full of zeros and ones. We might want them to be numbers. Okay, so what's a 0111 according to our little chart here? It's a 7. I'm going to preface it with a 0 though, and we'll see why in a minute. What is this 1001? That's a 9. What about that one? That's a 15. That's a 1. And what is this last one? 10. Okay, so if I was going to change this to base 10, it would be 07, 09, 15, 01, 10. Now why did I put zeros here? Because otherwise I wouldn't know whether I was looking at a 1 or a 15. I wouldn't know whether I was looking at a 1 or a 10. So by adding the zeros to make sure that each one took 2 places, I'm making sure that I know which one is which. But most of the time there is no data. You know, most of these have zeros in front of them. You know, that's a 0, 0, that's a 0, 1, that's a 0, 2, that's a 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8. You know, about 2/3 of them, about 2/3 of these zeros are wasted spaces. So if we're going to count in hexadecimal, hex means 6, we're going to add 6 more digits to our counting system. It's not only going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to tack on 6 more digits. And I chose A, B, C, D, E, F. So as we're counting our numbers, that's a 9. Whoops, that's an A. That's a B. That's a C. That's a D. That's an E. And that's an F. So if you have a number in hex and you're trying to convert it to base 10, let's pretend that we have the number 120B. That looks weird, but it's a valid number in base 16. What is it in base 10? Well, we have to know the powers. In base 16, this column is the ones column, 16 to the power of 0. The next column is the 16ths column, 16 to the power of 1. And this one is 16 to the power of 2. So we have a 256 column, we have a 16s column, and we have a 1s column. So if we have the number 1, 2b, that is 1 times 256 plus 2 times 16 plus, what is a b? What is a b actually in our base system? It's an 11 plus 11 times 1. And so 2 times 16 is 32. You add on another one, that's 33. You add that to 256 and you get 289, I think. So 12b in hexadecimal is 289 in base 10. Using this little chart here, let's convert these bits on the worksheet to hex values. Go back to the worksheet. So a 0, 0, 0, 0 is still a 0, regardless of whether it's hex or decimal. A 0, 1, 1, 0, what is that?
6.
That's a 6. And it's a 6 regardless of whether you're in decimal or hexadecimal. It's only when you get to 10 or above that you need to start substituting letters. What about 1110? That's a 14, which is an E. And the last two are pretty easy. 0101 is a 5, and 0001 is a 1. Now do the reverse. What is a B? A B is a 1011. And what is that next one? The D. Yep, 1101. That making sense to everybody? Rather than thinking about it, I'm just using this chart. And if I give this to you on an exam or a quiz, I'll give you this chart so you don't have to take the time to sit there and write it out yourself. So why do computer scientists use hexadecimal? Because it's a pretty clean way of representing bits in a readable form on a display. It's much more concise than merely using decimal. If we went back to this one, where I was converting this to base 10, I'm going to represent this as base 10 by putting a parentheses 10 after it. If I wanted this to be in base 16, same numbers. Well, what's an 0111?
7.
It's still a 7, but we only take one place to do it. What's a 1001? 9. How about all ones? F. And that's a 1. And what's this last one? 8. Yeah. So we could squeeze these all together. And that's what that is in base 16, or in hex. Half as long. More concise way. And it kind of breaks down cleanly. Every 2 hexadecimal numbers is equal to a byte, because every 2 hexadecimal digits is equal to 8 bits. So you can go to something like hexed.it, and we can upload a file, and we'll be able to see the bytes that are in the file, but they'll be represented in hexadecimal format. I'm just going to pick a random file here. And there we go. So the first 4 bytes of this Word doc are 50 4B 0304. And this is hex, as we can tell, because there's a B in it. If we wanted to change these to zeros and ones, we could do that pretty easily, just by the same process we did on the worksheet. Different file types have different bytes at the beginning of them. A JPEG has a certain series of bytes up at the beginning to indicate that it's a JPEG. An MP3 has another series of bytes in front of it to indicate that it's an MP3, and so on. A Word doc, probably every Word doc we open will have these bytes in it, a 50 and a 4B. Let's see if that's true. I'm going to open another one, if I can find one. Yeah, 54B. So, similarly. If we scroll up and down, this is what's known as the ASCII representation. Now, the Word doc's got a whole bunch of padding in it. If we scroll down, eventually we may see the text in ASCII form, but then again, we may not. It's probably not being encoded in ASCII anymore. ASCII is an 8-bit character set. Text files are encoded in ASCII. We can open up a text file. Let's find a text file. Here's one. And there's our nodes. It doesn't look like nodes because this is unfortunately an assignment, that's talking about hex. That's a real bad example. But if we did have any English writing in it, then we'd see it over here. We see a little bit, base 10, decimal, and so on. All right. That's just about enough of bits and bytes for now. Yeah, that's definitely enough. Go ahead and save your document and upload it to the Dropbox. And we're going to go merrily away onto the Chapter 2 PowerPoint. Wow, I guess I hate Chapter 1 so much I didn't even put a PowerPoint of it up there. Where'd the PowerPoint go? Oh well. Kind of indicates that I'm not going to ask you questions about Chapter 1 for the exam, but I will get it up there. Okay, I'm going to download the Chapter 2 PowerPoint so we can begin lecturing on that. Okay, so if you've taken an earlier programming class like 1113, you've been introduced to the idea of pseudocode. What pseudocode is, it's an English description of what you want the program to do. It's pure English. It's not a programming language. It kind of looks like a programming language, but really you're totally winging it. We want this program to say, enter a length, and then to allow the input of a length. And then print enter a width, and allow the input of that width. And then we want to set area equal to length times width, so that we can print the area is area. Now, this kind of looks like Python, but not really. It certainly doesn't look much like Java. When we code this program in, we're going to see that it looks significantly different than the pseudocode. Each one of these will be represented by at least one statement in our code. And we'll be learning what statements correspond to getting input from something or printing something. So the print statement should cause the specified item or items to be displayed. So the first line in the above algorithm causes this to be displayed, enter a length. We can print all sorts of different things. We can print numbers, we can print strings. If you want to print a sequence of characters, you surround the characters with double quotes. In other programming languages like Python, you can switch between single and double quotes. But in C++ and Java, double quotes is mandatory in order to print a series of characters. And then the idea of inputting. What an input statement is supposed to do. Now there is no input statement in Java, but there is in pseudocode, and there is an equivalent command in Java that will pull input in. So the input statement is supposed to cause the algorithm to sit there and wait for the user to type in a value. And then after the user enters a value, whatever they typed in is stored in the variable. A variable is a little box, it's a little place, it's a little series of bytes in the computer's memory that can hold a value. So this is saying please enter a length, and then we're letting the user type in a length, and we're storing it in a variable called length. So that, why is it called variable? Because it can vary. Later on you could store something else in the same name. And then later on we can use that variable, like when we calculate area, we will say it's equal to length times another variable. Prompting is the act of displaying a message and then letting the user type in their answer. That's a prompt. We are prompting the user to enter a value. So typically the print command is just about the first thing that you get shown whenever you start programming. And we did a hello world kind of thing. The next thing you learn is the assignment statement. In pseudocode, you see set area to length times width. Now we're never actually going to type that into Java. But in Java, what you do is something like A is equal to 10. That copies the value of A into the variable, copies the value 10 into the variable A. It assigns 10 to the variable A. This is called the assignment operator because it does an assignment. It copies 10 into there. You could do something else. You could say pi is equal to 3.14159. You could do name is equal to Joe Bob. Why am I typing in all caps? I'm not really sure. Each one of these is an assignment into a variable. Now some languages that's perfect. There's nothing wrong with doing this. In Java this will not work. In Java you have to declare your variables before you use them or during the first assignment. Now this is a whole number. So I'm going to declare a as an int. This is a floating point number, so I'm going to declare it as a double. Double is Java's default floating point type. And this is a string of characters, so I'm going to declare it as a string. Now if I entered this code into a Java program, it would now work, except I have to end each directive statement in a semicolon. So the assignment statement, what you're doing on this side of it doesn't just have to be a single value. It can be a calculation. It can be an expression. We could do a is equal to a times 20. Well, when this is done, what will a equal? What does a equal first, right now, after we've executed these four statements? By the time we get here, what does a equal? 10. So we are going to perform this calculation. Well, not we. The computer's going to. It's going to multiply 10 times 20, which is 200. So by the time this statement's done executing, a now equals 200. So this can be just a simple value, a hard-coded constant like 10. A hard-coded constant like that is known as a literal. This is a literal integer. It's literally typed into the code. This is a literal floating point number. This is a literal string. This isn't a literal because it includes a variable in it. It's got a literal here, but that's a variable. So assignments in Java. Int result, we declare the variable, and then we copy 0 into it. We assign it. The very first time you give a value to a variable, you can also call it initializing. I initialized this variable with the value 0. Now we're going to calculate something. 1 plus 2. That is the expression. That gets calculated. It's 3. And that is assigned into result. It's copied into the result variable. So when we issue our print statement, it will print out 3. Then we do result is equal to result minus 1. Well, what's on the right-hand side of the assignment operator? That's an expression. Result was equal to 3. 3 minus 1 is 2, so 2 gets copied into the result variable. So now when we print it out, it will print out a 2. And these are comments. Comments just describe the program, how the program works, what it's doing. That's declaring a variable, that's copying a value into it. I do want you to use comments, however you don't have to comment every single line of code. That's kind of overkill. You know, on the first slide showing Java code, it's okay to comment every line of code. The if statement. Right now we've talked about assignments and we've talked about print statements. Well, now we need to determine whether we are going to do one thing or another based on the value. And so the syntax of an if statement will support 3 different forms. There's an if something, do something. There's an if something, do something else, do something else. That's like, if you have money, go out and eat, else stay home. And then there's if, else, if. And you can chain if, else, ifs. That's like, if I have money, go out and eat. Else, if I have friends, borrow money from them. Else, stay home. Yeah. So the format for the if statement is if followed by the condition. And in this language, the condition has to always be in parentheses for an if statement. And then some statements, one or more statements underneath that. This is a block of code. So we should include that block of code in parentheses. I'm going to go ahead and start NetBeans, and I would like for you to as well. And we're going to write a little program. And the flip side of this program, once we're done with it, will be, I'll give you an assignment based on this. Okay, so once NetBeans is loaded, I do File, New, Project. File, New Project. I choose a Java application. I click Next. If you don't want to save it in this directory, in the project location, wherever that is, I'm going to change this to save it to my desktop so it's easier. So I'm going to click Browse. and go over here to the desktop. And there we go. The name of this project, let's call it well, it's short assignment 2, but let's call it short to water, because it's going to print whether the water is a liquid, a solid, or a gas. Whether it's boiling, whether it's freezing, or it's a liquid. And then I click Finish. All right. I need to increase this font size. Is this the very first program we've done, or did we do a Hello World? We did a Hello World, but we were in the other room, and that's why my settings are not correct. Now I recall. I need to increase my font size, so I'm going to go to Fonts and Colors, pick a much larger font. All right. Hopefully that's easier to read. Every program you write, I want you to name the class. In this case, it's called Short to Water. And I want you to put your name in it. Don't put my name. And then we're going to describe what the program does. This program determines if water at the specified temperature is freezing, if it's a solid, liquid, or boiling. Now, if you grew up in a country that uses the Celsius, then 0 is freezing and 100 is boiling. In the English and the imperial systems, then 32 degrees is freezing and 212 is boiling. So you could use either one of those in your program. Now that I have the author up here, I don't really need the author in this comment down here, so I'm going to delete those comments. And I don't really need this comment either, the one that says param args. That's just kind of wasting space. But we need some variables. We need at least one variable. Maybe we'll use 2 variables. Let's make a variable that is a temperature, and I'm going to declare it as a floating point variable, as a double, so that it could hold a fraction. So it could be like 212.5. And I'm going to call it temp, short for temperature. That may not be the world's best variable name because it looks like a temporary value, but that's good enough. Now I'm going to declare another variable, which is going to be a string. Now, string is a different kind of data type. It's not a keyword. That's why it's not in blue. It's what's known as a class. That's why it had to be capitalized. In some other languages, strings are not capitalized because they're not classes. But in this one, okay. And we're going to call this one state. And the state could either be boiling, liquid, or freezing. We're assuming at standard pressure for you physicist types. Okay, so let's assign a temperature. Ideally, we would ask the user what the temperature was. But that would take adding some code. We'll do that in a minute. I'm just going to arbitrarily say that it's now currently 72 degrees. And we want to find out what state. Okay, I'm going to assume English units. If the temperature is less than 212, no, if the temperature is less than 32, and now I'm using curly braces. The curly braces are the shift of the square braces, which are next to the P. State is equal to freezing. Else, if temperature is greater than 212, state is equal to boiling. And then finally, if neither one of those conditions is true, state is equal to liquid. And I forgot to put a semicolon here, and that's why I'm getting this underlined and a little red mark out here. So every assignment has to have a semicolon at the end of it. Any statement that precedes the creation of a new block of code, like an if statement, or the main word here, or the class word here, does not require a semicolon. The rest of them pretty much do. So every time you see a brace, there will not be a semicolon in front of it, on the line above it, or even on the same line. Otherwise, you should always see a semicolon at the end of that line. Now that we've done this, we want to print what the water is. So I'm going to do system with a capital S dot OUT dot println, PRINTLN. The water is space, end quote, plus, and then the state. State being the variable that contains either the word freezing, boiling, or liquid. Now let's build it and run it. There's a little icon next to the green arrow that looks like a hammer and a broom. I'm going to click that. And I'm not seeing my output. There's no output window currently showing. So I'm going to go up to Window and choose Window Output, and then I see my output. And the output says build successful. Now when it compiled, it created a jar file. A jar file is not an executable file. It's not binary. It's not machine language. It's something closer to assembler. It's an intermediate stage. And the Java virtual machine then uses that jar file to actually run the program. And it gives you a command that you could enter into the command line in order to run it. But we're not going to do that. We're just going to hit that big green button. And I run it, and it says the water is liquid. All right, now I'm going to change the program just for giggles into Celsius. I'm going to make the freezing point of water 0 and the boiling point of water 100. You don't have to do that, but you can. Then I'm going to run it. The water is still liquid because 72 degrees, while being quite hot in Celsius, your skin would, fry in that temperature, is not past the boiling point of water. But let's make it below freezing. Come back and edit the value of that variable and set it equal to a negative 100 degrees. Alrighty. Our program is done. Is it running for everybody, or are you getting syntax errors? Let me get away with blathering too much. Yeah, you can do that. It should say boiling. You're doing it correctly. You should always test all possible states. Since I've written this program, I should make sure that depending upon this value, it will print freezing, boiling, and liquid. When I tested it up here, I only tested freezing and liquid.
Excuse me, I could see my result for white liquid or boiling.
We don't have a print statement at the bottom. I'm going to have to scroll my thing down, and then you can see the print statement.
Yes, the system.
Sorry about that. My output window covered it. Here we go.
Thank you.
Sure thing. Gotta go. Good deal. Here's Rocky. You can see a couple of other errors. String has to be capitalized. So come up here and put this there. these lines here above that last else that you have. You need that code there. Now I'm trying to resist the urge of making this more complicated. We can make this a temperature conversion program where if it was, 100 degrees Celsius, it would print out that it was 212 Fahrenheit. We do want to change the program, though, to ask the user for the temperature. So that will require another change. We have to go back up to the top, and we have to add an import. I tell you what, I'm going to skip adding the import and show you how to add the import using netbeans, which I shouldn't do because people then start happily clicking on every error hoping that it magically fixes the problem. But in this case, it's okay. If you know that what the choice it's offering you is correct, it's okay to click it and say, please fix it. Okay, so the thing that gets input into this Java program is what's known as a scanner. I'm not quite sure why they use the word scanner, but I mean because it's not like a flatbed scanner where you feed it a document and you get a picture. Instead, it reads the keyboard. It is also a class, so it has to be capitalized. SCANNER, and then we have to give it a name. I'm just going to give it the name of IN. That's the variable name. But I have to create the scanner. I have to instantiate it. I can't just do that because it doesn't know what it's reading from yet. And here is where our poor Python students start going, I hate this language because it's much more complicated than Python. It's not that it's much more complicated, it's just that it doesn't have as much built in. So we do scanner in is equal to new scanner, and then in between some parentheses, we have to type in system.in. That is going to cause an error because it doesn't know what a scanner is. A scanner is in a class. We have to import that class. So if we come over here and look at the error, we hover our cursor over the error, it says cannot find symbol. If we click that error, it gives us a whole bunch of choices, and only one of them is correct. Please add the import for java.util.scanner. NetBeans is smart enough to know that if we type the word scanner, it's probably supposed to be that class, java.util.scanner. So I'm going to click that red arrow, it's not an arrow. Choose the top one, which is add import for java.util.scanner. And then if I scroll up, right under my package statement is now an import statement. I could have typed that in by hand. Then I wouldn't have had that error. Now, just because I showed you that you can click on the red error and fix your problem doesn't mean that you should always do that. I'll give you an example. What if I forgot that I was using lowercase temp and I made the next time I used it uppercase temp? That's going to give me an error. I come over here and I click on the error. Here's my choices. Create local variable temp. Well, that didn't quite fix it. Let's try that again. There. Woohoo, it's fixed. But it's not, because this is a lowercase temp. And so this temp is still equal to minus 100. This is a completely different variable. That was the wrong thing. That's the wrong fix. So don't blindly click on the red errors hoping that you're going to be able to make all of the problems in your code go away. But if you recognize the error, like scanner, then it's okay to go ahead and say add the import for scanner. If you don't want to use that at all, you can just remember that you need to add this line of code up to the top of your program above the class statement. All right, let me get rid of that one. That was a mistake. Now, just because we added the import for it doesn't mean that we're actually using the scanner yet. We created a scanner, but we haven't used it yet. So let's actually use that. We're going to prompt the user. So find that line that said temperature is equal to whatever it was, minus 100 in my case. You made it equal to something else. Change that line. Here's what we're going to change it into. Temp is equal to, and our scanner is called IN. We could have given it any name we wanted to. We could have called it Barney or Fred. But IN dot next double, and the D in double is capitalized. And what that does is it allows us to type in a number. However, the user doesn't know what they're supposed to type, so we need to put a print statement before that. So above the line that says temp is equal to IN dot next double, I'm going to do another print statement. System.out.println. What is the temperature? Now I'm going to run it. I'm going to build it. I'm going to press the little hammer broom thing. And then when I click the green arrow to run the application, it says, what is the temperature? And I can type in a value. If it's 1,000 degrees, the water is boiling. Well, I certainly hope so. Now, to make it a better program, I'm going to add some comments. Above that system.out.println, what is the temperature? I'm going to add the comment, prompt the user for the temperature. And then above the top if statement, I'm going to add a comment that says, determine the state of water. State of water based on temp. And then above that final print statement, I'm going to add the words display results. This is the final version of the program. I'll go ahead and copy it and paste it in again. The homework is going to be to write a very similar program, but I'll give you the specs for it at the end of class rather than telling you now, because otherwise you'll start working on it now. When we're working on a different part. Now that I'm not going to do anything else to this program, I think there was something I wanted to mention. If you have not installed NetBeans yet, out in Contents, if you click Course Tools Contents, you'll see last Thursday's lecture. There's another file here called Using NetBeans. I'm not even sure what that one is. I'm going to drag that one and get it out of the way. But there's also a video called Installing NetBeans. So, installing NetBeans hopefully isn't too hard, and you may have already done so. But if you haven't, go ahead and watch the video. Now, I did it on Windows, but you can install NetBeans on a Mac just as easily. We're actually getting pretty close to the end of class. I will create the assignment now. So, the program. Use the code below or your code for short assignment 2 as a basis to solve the following problem. So you're going to change your code. What I want the program to do is ask the user for a numeric grade, and then determine if that grade represents an A, B, C, D, or F. And the rules are, if it's 90, if the grade is greater than or equal to 90, then it's an A. If it's greater than or equal to 80, these are assuming that you're using else's. If it's greater than or equal to 80, it's a B. Else, if it's greater than or equal to 70, it's a C. We know the grading scale. Else, if it's greater than or equal to 60, you made a D. And then finally, else, it's an F. I'm going to change the word of this from numeric grade to numeric score, because a score is a value, whereas a grade is calculated based on that value. So if score is greater than or equal to 90, the grade equals an A. Remember, you have to put double quotes around strings. And the double quotes should not be things like that word adds. Let's see if I can find a correct double quote and paste it into there. And then we want to print the grade out. So that shouldn't be too hard to do. If you look at the program we've currently have going, you ought to be able to modify it or write a new one that looks similar to it to perform this grading system. Ignore the fact that I've spaced it out weirdly. Now this is not good Java syntax. Remember that the condition has to be enclosed in parentheses, and that you're going to need your curly braces, and that assignment statements need semicolons at the end. So we ask the user for the numeric score. 2, we determine if that score represents an A, B, C, or D. And then 3, we print the score out. Okay. So use the code below or your code for assignment 2 as a basis to write the code that will solve the following problem. Okay. We will call this homework 1, I believe. it'll be due a week from now. So Monday at midnight. I guess it is. It's due yesterday. Do y'all have it done? Let's fix that. Thanks.
What if you haven't invented time travel yet?
Yeah. It's due Labor Day. Get it done before Labor Day. Enjoy the weekend. Go home and do it tonight. Alrighty. So I guess we should make an in-class assignment. It looks like there is already one called temperature. Let's just move that up. The instructions may not be exactly the same, but they're close enough. Upload your current program into that directory. I'll put it up in the do programs, and I'll walk y'all through it, uploading one more time. Alright, so I have a program I want to upload. You could just give me the .java file, or you could upload the entire zip. Either is cool, but here's how to give me the entire zip. Why would you want to do that? So that you could then download the program again at home, and you have everything already set up in a project. So what you do is you select the project. Right now this one's just called Short 2 Water. Do File, Export Project to Zip. And it's got some stupid path, local, temp, short, whatever. Browse and go to whatever you really want to save it to, like the desktop, to your Java folder on your desktop or whatever. And then give it a good name. This was short assignment 2. Tack your name onto the submission. And then give it the extension .zip, because if you try to upload a file with no file extension, D2L will reject it. And then you click export. That creates a zip file. We can see the path to it there. Mine is in JG Thompson Desktop Java. Go back. Find the in class 2 Dropbox. Where did it go? Oh, it's right there, in class 2. They're out of order, but okay. Click on the folder in class 2. It's the second item right now. Click add file and either just give me the .java file or that entire zip. Go to where you saved your export. Click add, but that doesn't actually upload it. Then click submit. And then if you see file upload results, submission successful, that means I got it.